Our speaker today, Dr. Thomas D. is Associate Professor of Economics and Director of the Public Policy Program at Swarthmore College. He has a variety of interests in education policy in areas such as the non-cognitive outcomes of school choice, the effect of expectations on student performance, interactions between teacher and student race and gender, and student outcomes, just a real sort of cornucopia of interest in various educational interventions. But the one factor that really integrates Tom's research is he applies extremely rigorous methods to all of his evaluations. And those PhD students who survived my program evaluation and research design course will recognize many of the sophisticated techniques that Tom uses, including random assignment, regression discontinuity, and instrumental variable analysis. So today he's here to present his latest research. It is using experimental design and evaluation of a cash penalty, cash incentive sort of intervention in the educational environment. So I give you Tom D.
Thank you. Thank you for that generous introduction. And I'm really glad to finally get a chance to visit Arkansas. There's just so much that's exciting going on here now with regard to education policy research. So I'm glad to have an opportunity to visit. So I'm going to be talking about conditional cash penalties. And in particular, this is an evaluation of a policy in Wisconsin, Learnfare, that linked welfare payments to meeting school attendance targets. But in order to just set the table a little bit, obviously, basic levels of student engagement and motivation are really important in the development of educational outcomes. That's uncontroversial. There's growing new evidence that they also directly matter for labor market success, that people who are engaged and motivated, even controlling for their educational achievement, do much better in terms of life circumstances. And there's a concern that the role of these non-cognitive skills may play a really critical role in sort of perpetuating cycles of poverty. So that's one of the ways people have been motivating a growing interest in trying to use financial incentives to get students and families to make the sort of valid human capital investments in themselves that we think they should, that are even sort of welfare improving for themselves. So there's a whole lot of new interest in this area, and it's partly, I'm going to list for you the number of studies that have been going on within developed nations on providing students directly with incentives for improving academic performance. And a number of these studies are just sort of breaking now, about to be released. But there's also a pretty large extant literature on financial incentives in developing countries, and some of you may have heard of this. The seminal program was Progressa, which was introduced in Mexico, and its basic structure was that families whose children met school attendance targets, as well as met basic medical needs for their children, getting checkups, etc., were given a cash transfer that was equivalent roughly to the amount the child could earn through child labor. And so that program had an experimental evaluation. It appeared to be really successful. It's sort of been replicated throughout Central and South America, as well as parts of Asia. And there's even a trial based on this going on in New York City right now, which I can discuss. So a lot of interest in the role of providing either family-based or student-based financial incentives for human capital investments. Okay, so what am I doing in this study? Well, in this study, I'm trying to draw people's attention to an earlier version of these types of programs, Wisconsin's Learnfare program, that I think has been misunderstood for reasons I'm going to unpackage, and that I also think is really critical in terms of, has some critical insights in terms of policy design features that I'm going to want to underscore. But the basic structure of the program, which I'll describe in detail, is that it lowered welfare grants for families where students who were covered on a welfare grant did not meet school attendance targets. And in framing this broad question, I think, sometimes it's framed as simply whether student incentives work, but, we're surrounded by incentives, both students and everyone, throughout life. And I think a more subtle and appropriate way to frame the broader question here is, how can these incentives work effectively, if at all? And so that's going to have to do with issues of what exactly is the nature of the targeted task and to whom is this policy targeted, as well as questions of how well it's implemented. All of those are going to be part, I think, of a sensible policy consideration of this. Okay, so given this research landscape, why do I think Learnfare has something to say that people haven't been appreciating? Well, it has a number of features that make it unique. First of all, it's a family-based incentive like Mexico's Progressa program, right? Like a conditional cash transfer program, but in a developed nation context. And it's really the first one to do that. And the one going on in New York City is in many ways the second. So the other critical thing is the way the incentive was structured is that it's a penalty on an endowment rather than a reward for meeting a target. So why do you think that might matter? Well, there's a lot of interest now in sort of policy interventions that are themed on the insights from behavioral economics, that leverage what we've learned about cognitive biases in human decision making, right? So many of you may have read, for example, this recent Thaler-Sustein book called Nudge, which is about sort of utilizing what we know about decision-making errors to structure policies that have a greater impact. Well, there's a sense in which Learnfare did that, because one particular type of cognitive bias that's been well-known, well-documented for a long while is loss aversion. People exhibit an asymmetric aversion to losses in money relative to equal gains in money. So because Learnfare sanctioned an endowment, something that people already owned, its dollar-for-dollar impact might be larger than a program that gave people money for meeting a target. Okay, so it has that interesting nudge-like feature. The other thing is there's a lot of concern, particularly coming out of the psychological literature, on possible unintended negative consequences of giving people incentives. And in particular, there's some literature to suggest it can be a problem when the behavior you're targeting is one that people don't feel they have the capacity to meet, right? I mean, you could give people incentives to fly to the moon, right? But they're not going to do it unless they have a rocket. And so there's some, there's been concern in that spirit about giving people incentives for meeting really high thresholds on test scores that a lot of at-risk students might feel the incentive is basically irrelevant for them, right? Because they have no capacity or expectation they'll be able to capture that. Well, in this regard, Learnfare is interesting because what it targeted was school attendance and not performance. And so they might feel it's a little more effort responsive. And I'm also going to argue educationally and economically relevant. And it's going to come back and sort of make a case for why we should care about attendance. And so the other thing that I think is interesting about Learnfare is, a common criticism of random assignment studies is, well, you found an effect within your little rarefied study, but maybe it has limited external validity for what goes on in the real world because everyone knew they were in a study. There were all kinds of special supports and circumstances that surrounded the intervention that was being evaluated. The Learnfare evaluation was a little bit different because the policy was at scale statewide for 5 years before they did the random assignment evaluation, which is not uncommon, right, in policy circles for implementation to sometimes speed ahead of evaluation. But I think that's a little bit unique. It makes this study a little more robust to concerns about external validity. Okay, so a quick discussion of some of the concerns people have had about incentives, student incentives used in education. There are a lot of psychologists who worry that extrinsic rewards can have unintended consequences because they lower intrinsic motivation. And the seminal study in this literature is the DESI one, where I think the way it was structured, if I'm recollecting correctly, is they paid some college students to work on puzzles, and others were just asked to work on the puzzles. And then when they took the incentives away, those who had been previously paid to work on puzzles no longer chose to work on puzzles. And so the argument was their intrinsic motivation to engage in that task was degraded once the incentives were removed. There's sort of an economic gloss on this, where some theorists have argued what may be going on here is kind of an asymmetric information problem. People don't know whether they're really good in a particular domain or should identify with it. They have imperfect information about that, and they deduce whether they're good in that domain by the incentives that other people provide them. So for example, I like to give talks like this because I feel intrinsically motivated by the topic, and if you were to say, Tom, there's an extra $100 in it if you don't bore us to tears today, I would take the money. But there's a part of me that, according to this theory, my intrinsic motivation might be debased because you felt you needed to give me that money to do well. So anyway, some interesting literature. There's been a contrarian pushback by some psychologists arguing that, look, it doesn't make sense to talk about this in a sort of completely homogeneous way because, extrinsic rewards might be harmful if your baseline level of intrinsic motivation is high, if you're that college student in a lab study. But this reinterpretation of the evidence has suggested for those whose baseline level of intrinsic motivation is low, extrinsic rewards can be helpful. And some of the experimental economists who've worked in this area, this is a nice review article of this literature, argue that it's really important to focus on what the task is that's being incentivized. People have to feel they have the capacity to earn the rewards for the rewards to matter. The targeted task has to be effort responsive. Okay, so let me give you a quick overview of some of this literature. And it's kind of exciting because often when I do literature reviews, it's hard to find things that are really credibly identified by random assignment studies, but there are quite a large number of random assignment studies in this area. I already mentioned the seminal Progressa program. Michael Kremer and colleagues did incentive study in Africa with Kenyan schoolgirls and found that they did get an increase in test scores without any evidence of pejorative consequences. The benefits even spilled over to boys who weren't eligible for the incentive, and I think this is more important, girls who were far from the test score target still did better, even though they were extremely unlikely to meet that target. So there were numbers. This slide is all studies done in higher education. There was a study at a Canadian university that found effects for females, particularly when the incentives were linked with support services. There was a study at the University of Amsterdam that found the first-year performance of students generally improved with incentives, though they found some negative effects for those with low baseline math achievement. And this is the only field experimental evidence I've seen that's consistent with these concerns about debasing extrinsic motivation. Some of you may have heard about this really interesting opening doors evaluation, which was done at Louisiana community colleges. It was managed by MDRC. It got cut short because of Hurricane Katrina, and so I think they only had 1 year of data, but they found that providing parents attending the community college with financial incentives to meet enrollment and GPA targets was really quite successful. My third slide of field experimental evidence, I mean, you can't say that very often, right, is just financial incentives in K through 12 in developed countries. So we've got this new paper, just came out in the American Economic Review, on cash incentives in Israel for getting the Bagrut, which is a matriculation certificate, and found effects for girls, though not for boys. Eric Bettinger's work in Coshocton with elementary school students found increases in math scores, no debasement of intrinsic motivation, but also no effects on other subject achievements. This is my placeholder for all the ongoing projects of Roland Fryer. These are references to news articles discussing them. And I think he's about to present some public results from that soon. They have studies going on in these 3 cities, and I think also Dallas, that target different things. And there's also this conditional cash transfer program going on in New York City right now. And I was just at a sort of pre-release conference for that last week, and it's really an interesting program, though they had actually 22 different incentives embedded in it, for job training, for health care, extra money if your child had a library card, etc. And so you're going to be hearing more about that, I think, very soon. Okay, fourth and final slide concerns these welfare waiver demonstrations that are like the one I'm studying. So there were 7 random assignment studies of linking school attendance to the threat of reductions in welfare benefits. And I'm distinguishing these from conditional cash transfers by calling them conditional cash penalty programs. And again, the distinction here is one that's rooted in behavioral economics and this nudge literature, because the fact that it's going to leverage loss aversion rather than the potential of gaining the income may really amp up the behavioral impact of it. Okay, So of these 7 studies, reviews of this literature have divided them into 3 that relied largely on sanctions, and the conventional interpretation is they had negligible effects on enrollment and attendance. And this includes Learnfare plus programs in Maryland and Delaware. 4 other programs found some effects, particularly on enrollment, according to this literature review, but they combined sanction threats with a lot of non-trivial support services. So what really was driving those potential impacts isn't clear. So it's not really telling us, was it the incentives that mattered? So that's the conventional interpretation, but I think they got the Wisconsin Learnfare result wrong. And so that's what this study is. It's a reanalysis of the experimental data from the Wisconsin Learnfare program. So let me tell you a little bit about that, and give you an overview of why I think they got it wrong. So as many of you probably know, Wisconsin was a leader in innovating with welfare throughout the mid to late 80s, early 90s. And Learnfare was one of the very earliest innovations they pushed, the centerpiece of the first round of their initiatives. So, and it's actually been really successful. 38 states now have Learnfare-like restrictions on welfare receipt. So the way the program worked was, it was applicable to kids who were receiving, or families receiving AFDC grants who had kids aged 13 to 19. Okay, so an AFDC grant would become subject to the Learnfare restrictions when a covered child turned 13, or if they were part of a new case, so you're 15 years old and your family goes on AFDC. So what they would do is they would review school attendance records. And if you were not enrolled, or you had not graduated from high school or earned a GED, you were immediately removed from your family's welfare grant until your enrollment could be reestablished. So this gives you a sense of what's the amount of the incentive? It's driven by that child's contribution to the family's AFDC grant. If that child should be in school or have graduated and hasn't, it's as if that child did not exist in terms of getting the welfare grant. So that creates some heterogeneity in the incentives. And if, if a student was enrolled, there would be these twice-a-year checks, and if there were 10 or more unexcused full-day absences in a semester, they moved to a monthly attendance monitoring regime. And they would receive monthly notices of attendance requirements, as well as some offers of support services. So once a teen's in monthly monitoring, if they have 3 or more unexcused absences in a month, they're told they're getting a 1-month benefit sanction, right? Unless they can establish some good cause. But Wisconsin had waivers that really made this restriction pretty binding. So for example, they did not have to provide assessment and support services prior to sanctioning, and they also were excused from the requirement that there be conciliatory procedures to resolve disputes. I mean, families were given some opportunities to contest the sanction, but the state could move pretty quickly to make it happen. So the sanction amount, again, it depends on the covered teen's contribution to the family grant. So if you're a single mother and you're the sort of head of household for the grant, the sanction could be quite high, right? Because if you're not in school and you haven't graduated, the dollar amount could be nearly $200. But if you're one of several kids that's contributing to the grant, it could be in a lower range. And to benchmark this, the average monthly grant was about $460 during this period. Okay, so Milwaukee County is worth talking about for a moment because it has half the state's welfare eligible population, but it really had a very different Learnfare experience than the rest of the state. So there were lawsuits alleging due process violations because the attendance data in Milwaukee Public Schools was just so atrocious. And so there was a 1992 settlement to this that essentially established additional attendance verification procedures for Milwaukee County prior to the imposition of a sanction. So what that ended up meaning was that outside Milwaukee County, there was a tight temporal link between an attendance violation and the financial sanction. It would be as little as 2 months, while within Milwaukee County, it averaged 6.5 months. And there was also a 1995 review that found even with these additional procedures, they were still making lots of type 1 and type 2 errors within Milwaukee County. People who should have been sanctioned weren't being sanctioned. People who should not have been sanctioned were being sanctioned. So what I do in my study, and what was done in the primary evaluation, is to look at Milwaukee County and the other counties in the study separately. Okay, so what do we know? What about evaluating Learnfare's impact? So, of course, when you have these federal waivers to innovate with welfare, it requires some type of evaluation. There was an early non-experimental evaluation that suggested Learnfare didn't improve attendance, but it was pretty observational in nature. And the study itself acknowledged we don't have the strength of a random assignment study to really credibly identify the impact of the program. As an aside, there was a lot of political theater surrounding the release of this too, and the authors felt, I think with some justification based on what I've read, that the state was trying to suppress their report, right? And they sort of fell on their swords as they released it. But the political discourse moved on and garnered support for a random assignment evaluation, and this Fry and Casper 97 is the final report on that, and that's what I'm reanalyzing and I want to tell you about. So it was based on the participation of 10 counties, so they chose then to create representativeness, and in the interest of time I'll just show you where they are on a map. The dark counties are what apparently passes for urban in Wisconsin. So Eau Claire, La Crosse, the mean streets of Kenosha are all the urban ones. And they stratified in selecting the counties to make sure they had some rural ones as well. And so how did this study proceed? How did people get into this study? Well, they had to meet the basic requirements of Learnfare participation, age 13 to 19, not already a high school graduate or a completer. And most people entered the study because they were part of an ongoing AFDC case, and they aged up to 13. But some entered because a part of a new case, and a few rare cases would be 15-year-old living with their grandmother in Illinois, moved back with their mother in Wisconsin, then they were subjected to Learnfare. So there's a small bit of exclusion if you had a sibling who was older and already subject to Learnfare restrictions. They worried that would contaminate your potential exemption from Learnfare as part of the evaluation, so they excluded families that had those birth order issues. And then what they did was they just collected baseline data, made an eligibility determination, and then did random assignment to either the extant Learnfare restrictions on your welfare grant or to being exempted from it. So what I'm calling the control group in this scenario is the group that was exempted from these attendance requirements. Though in a real sense, they're the treatment group, right? Because the requirement was everywhere, and they were not subject to it during this study. So, but the teens who did get the Learnfare treatment received the conventional introduction, subject to its conditions, and the teens in the control states weren't. So there was a 14-month entry period where over 3,000 students entered the study in these 10 counties, and I'll give you a flavor here of the structure of the data. So they started entering in March '93. You can see the 14 months of entry here, 3,205 entered. And then they gathered data over 6 semesters. And one of the things I want to point out here is notice that there's a lot of attrition in this study. So by spring '94, in a world where you get data on everyone who entered the study, you expect this number to be 3,205, and it's not. It's roughly 400 people who were randomly assigned you do not have attendance data for. And that number shrinks all the way down to 2,000 by the final period of the study. Now, part of this was that they just couldn't track people. Part of it was how they treated high school graduates, which I want to emphasize. But this is a research design problem that deserves careful attention because it can threaten the quality of the inferences you draw. Okay, so we've got data from these potential data from these 6 semesters, and so it implies that there are as many as 16,000 observations. There's a panel data structure here where you observe teens in 4 to 6 semesters, depending on when they entered the study. So over 16,000 potential observations. The key outcome measures are your enrollment data and your attendance data. I also have data on the rate of unexcused absences, and that is kind of useful. So for example, if you found no attendance effect, you might wonder, is it just parents are calling in and saying Johnny's sick today, so they don't lose the welfare grant and have an unexcused absence, or not? So having data on the prevalence of unexcused absences gives you a way to sort of tease that apart. Okay, and we've got baseline data on race, ethnicity, and a few other observables like were you a teen parent at baseline, were you a dropout at baseline. So the first thing I did was just replicate the original study, but I want to stress what I think they got wrong and be it really is kind of amazing to me. It just shows you, even with a random assignment study, right, there are plenty of ways to screw it up if you're not careful. Okay, so one of the things is they didn't really provide an explicit test for whether the random assignment worked. Right? I mean, you want to check that the baseline covariates are balanced across treatment and control states. Otherwise, you might worry that random assignment wasn't doing what you had hoped it would do. And I want to come back and talk more about that. The other thing is they didn't really pay attention to this issue of study attrition. Right? If people are leaving the study, potentially in a non-random way, related to their treatment status, you could get a biased estimate of the study, of the treatment impact. And there's a subcomponent to this, which has to do with how they treated high school graduates. So if someone graduated from high school, right, you would consider that successful in this framework. But you don't have attendance data for them any longer. There's no recorded attendance because they've completed their GED or graduated from high school. What they did in this study was to throw those people out of the analytical sample. Now the thing is, high school completers were overrepresented in the Learnfare treatment group. So you've got this non-random attrition of people out of the study sample, of people for whom the treatment was largely effective. Right? So obviously that's going to create a downward bias in the treatment impact. People for whom it was successful are overrepresented in the treatment group, and they disappear from the study because they weren't recognizing that high school completers, they may not have attendance data, but they still belong in the study. Okay? So, and also, the original study just ran single cross-sectional evaluations based on cuts of the data defined for people in their first semester, people in their second, people in their third. And this is potentially statistically inefficient because you're not getting the precision gains you could get from pooling observations across semesters. Now the other thing is, the conventional interpretation of the original evaluation was, well, it had maybe a short-term effect in some counties, but it decayed quickly over time. But that hypothesis wasn't really formally tested. And utilizing a panel data econometric structure allows you to test, does the treatment effect in the first semester differ significantly from the treatment effect in the second, third, fourth, fifth, or sixth? And so, as you'll see, when you do that test, you get a very different result. And it's also complicated by the fact that I think they got the appearance of treatment effects decaying over time because these high school completers were exiting the sample. So, okay, so this is me. I replicate their original results, and it works really. I can replicate them exactly, but I was going to say I don't believe them. So in the interest of time, I'll move on. Okay, so why do we want random assignment? Random assignment is going to give us a really strong claim to identifying the true impact of the intervention because it's going to balance across treatment and control states all the unobservables that might otherwise confound how we're going to identify that impact. Now, how do we check for that? Because it's possible that just by chance sometimes you might get an imbalance. And of course, we don't observe our unobservables. But what we can do is look at the baseline observables we do have and see whether they appear to be balanced. Now, why are we concerned here? Well, I didn't emphasize it much when I was describing Learnfare, but they had this very potentially decentralized random assignment mechanism. The research design report said they had a statewide specialist who was available to check eligibility, to do the random assignment, but it also said we might let the county officials do it as well. And I haven't been able to find out what really happened. And you're talking with Wisconsin officials in terms of the random assignment. But remember, this was an extremely controversial policy. And a lot of people didn't like it. Right? So it's possible that, especially if it was done within the county offices, that the experimental protocol wouldn't be met. So I wanted to check that by running these regressions. So these are one regression from Milwaukee County, one for the other 9 in the study, where the dependent variable is, did you get the Learnfare treatment? And the right-hand side variables are all these baseline observables, gender, race, etc. And if random assignment works, you would see something that looks like this in the 9 other study counties. No variable has a statistically significant relationship with whether you got the treatment. None of these baseline observables do. Moreover, this p-value is for a test of the joint significance of all these baseline variables. And so you've got a really high p-value. You can't reject the null that they're jointly insignificant as well. But now let's look in Milwaukee. Weakly significant impact with older people more likely to get the treatment. But this was the really strong effect. If you're a teen parent at baseline, you are significantly less likely within Milwaukee County to be subjected to the Learnfare treatment. So, I mean, I don't want to disparage people who are doing the study. I don't know what really happened in Milwaukee County, but one possibility is you're a case official sitting there during this 14-month window. You've got to make this determination, treatment or control, and there's a 16, 17-year-old teen woman with a baby in her lap, right? And you can imagine someone might say, you know what? You're in the control group, right? You're not subjected to this treatment, right? Because they probably didn't care very much about the study. Now, again, I don't know that that's true, and I'm actually presenting this paper in Madison later this semester, and so I'm hoping to run around the State House and see if I can find out what actually happened. Did they use the state specialists? Did they have county officials? How many county officials were involved in doing the random assignment? But this is a problem, right? So we can't trust the internal validity of the Milwaukee results. Yes?
Maybe it's obvious, and I'm just not getting it. Where's the Caucasian category?
So the Caucasian is the left out. So we've got or actually 5 category variable for race ethnicity. It's Black, Hispanic, Asian, Native American, white. So these coefficients should all be interpreted as shift in the probability of getting the treatment relative to the reference category of being white. Okay. The same thing, females relative to male. Age is relative to baseline age of 13. Overage for grade is, an indicator. For example, are you 15 years old but in 8th grades, et cetera? Are you a little high relative to the standard age for your grade? Because that's a really strong predictor or risk factor for dropping out of school.
So those aren't descriptive statistics.
No, these are the regression. These are 2
analytics.
regressions,
Yeah.
and these are the coefficients on those regressions, where the dependent variable is your treatment status. So what we're saying is the teen parents were significantly less likely to get the treatment. And you could worry about multiple comparison issues. I mean, this is a robust finding. You could Bonferroni that p-value, and it would. I'm going to make that a verb. To Bonferroni something. And plus, this overall test, right, is telling you there's a significant relationship between baseline observables and who got the treatment. So my claim is we can't really learn much that's credible from Milwaukee County's impact evaluation. Now, there's some other reasons we want to pay attention to Milwaukee, which, in particular, their issues with high-quality data systems, I think, are a strong cautionary tale for any school district or state that's thinking about doing these types of policies. But we're not really learning anything credible about the impact here. And it'd be hands above board if you were to run my regression specifications on the Milwaukee data, you're not going to find a treatment effect. Right? There doesn't appear to be one. But again, the random assignment is compromised in a way it wasn't in these 9 other counties. Okay, so we'll just discuss this quickly. I mentioned the attrition was really severe. Right? Now, part of the appearance of tradition was that about 6% of the sample completed high school and exited the sample. There are about 22% of the sample observations that they should have for which they don't have attendance data. And again, about 6% of that is due to these high school completers, but that still leaves about 16% of the sample that should be there isn't. Now, why is this a problem? Well, if people who got the treatment were more likely to leave, and you would imagine they had different propensities for school persistence, you're going to have internal validity problems. Right? You're going to have a biased impact by the non-random, potentially non-random exit of people from the sample. Plus, because some certain people aren't there, your external validity is a little compromised. Now, I would note, though, that if you left the sample because of the treatment, you can't get away from Learnfare, right? Because it's at scale statewide. The only hope for not being subject to its restrictions is to be in the control state within this study or to move out of state. So I think the incentives to leave because of the treatment are fairly weak. But we want to check this nonetheless. So what I do is run auxiliary regressions where A is an indicator for, should I have an observation for you, but I don't? Are you an attritter from the study? As a function of your treatment status, your baseline observables, and I've got fixed effects for the county you're from, the month you entered the study, and the semester in which you're observed. Now, in this specification, I've got a fully generalized set of interactions between them. So, for example, you want to capture things like, a particular county observed in fall '96 might have certain local labor market conditions that make attrition more or less likely. This is a way to sort of control for those types of things. And I can get into this if people want, but I'll skip over probably in the interest of time. I look into different types of imputation procedures for some of these attritors, and I present impact results based on those. So, but the basic result here is that each one of these cells is a point estimate from a single regression of attrition status on the treatment indicator. So, for example, this is, do you have attrition based on the recorded data, not even including the high school completers? This is the treatment impact on the probability of attrition. This is once I bring the high school completers back in, I say, look, your attendance rate is 1. Basically, you graduated high school. Is there a TC difference? Is there a treatment control difference in whether you've disappeared from the study? This is it based on the so-called last observation carry forward imputation, which if people are interested in that, I'll talk about it. But the key thing here is both for the full sample and for all these different subgroups, there's no significant impact of treatment status on whether you appeared in the study. So people were leaving, but not in a way that was imbalanced across treatment and control states. So I think for these 9 counties that have good treatment control balance, attrition is also not a threat, apparently, to the internal validity of the study. Okay, so let me get to the actual impact results, because I want to leave time for your questions. So the basic preferred specification is like the attrition one. Your attendance or enrollment outcome is a function of your treatment status, baseline observables, and a fully generalized set of controls for what county were you from, what month did you enter the study, what semester, which of the 6 semesters are we talking about here. The standard errors I adjust for clustering at the county by entry month level, and that seems to generate the most conservative inferences. For those of you who are interested in those kinds of issues, there's a really nice discussion in the new Angus Pischke book on how to think about doing this well, and they present some Monte Carlo evidence that suggests the kind of approach I've adopted here it works quite well. To try these types of heteroscedasticity adjustments in multiple plausible ways and use a rule of thumb that picks the one that generates the largest standard errors. Okay, so that's what's going on here. Now, I also want to test whether the treatment effect, how it may decay or amplify over time. So the way I do that is to interact the treatment indicator with, are you in your first study semester, your second, third, fourth, fifth, sixth? And I also do some results, and I'll probably skip them in the interest of time, where I define the outcome measures in different ways. So let me show you the basic impact results. So months enrolled was one of the key variables. And the way they defined this was not just as a binary indicator. They said for a given semester, you could, there are about 4.5 months in the semester. For how many of those months were you actually enrolled in school? So this variable has bounds between 0 and 4.5. The rate of attendance is out of how many school days your district had, your school had in the semester, were you there? And the rate of unexcused absences is constructed similarly. So what we're seeing here is across different specifications that try different types of fixed effects controls, consistent increases in enrollment, consistent increases in the rate of attendance, and pretty symmetrical reductions in the rate of unexcused absences. So this suggests that the increases in attendance were coming not so much from parents, well, it was coming from this source of people who were just not showing up and had never even bothered to call, right? So I think that's kind of interesting as an aside. Okay, so that's the imputation results. So here are the sort of dynamic treatment results. And as an aside, I want to come back and talk in detail about how to interpret the size of these effects, not just their significance, because I mean that's really important for the policy discourse. But notice here, in terms of treatment decay, yeah, these effects become statistically insignificant the longer you are in the study, but they're not decaying the way they appeared to in the original evaluation, right? This goes from 0.11 in the first semester to 0.14 in the fourth, and it's just that the standard error is blowing up. It's not that the treatment effect is decaying. And if you do an F-test on, are all 6 of these coefficients equal to each other, you can't reject the null that they are. And you see something similar here. So I wanted to stress one of the key criticisms I have of the original evaluation is that this common interpretation that the treatment effects decayed over time, I think is a completely unfair interpretation. Now, in fairness, this is a really imprecise estimate, and it's statistically indistinguishable from zero. But you can't legitimately, particularly given this F-test, say, oh, these had only short-term effects. I don't think that's a legitimate interpretation. So I've got some pretty pictures showing the shifting in the variables. Okay. So there were, one of the key tables there I skipped through in the interest of time were subgroup results. The thing is, you lose a lot of statistical power when you break things up by subgroups. There's suggestions that the treatment impacts were bigger for more at-risk populations, but it's hard to have a lot of statistical precision there because once you look only at teen parents, only at baseline dropouts, you've got a much, much smaller sample. So, okay, so let me explain what I think the basic results are and discuss some of these effect sizes and create a more chance for some feedback here. So basically, I want to suggest that the common interpretation of Learnfare is wrong, that it did generate statistically significant improvements in school enrollment and attendance. And the longer-term treatment effects are imprecise, but we can't reject the null that there was a common treatment effect sustained throughout the 4 to 6 semester study window. And again, as I noted, we had this symmetric reduction in the rate of unexcused absences. And I didn't stress these results, but if you look at different cut points in the distribution of attendance and enrollment, the effects seem to exist throughout the distribution. So does it matter? Let's talk, there's a statistically significant effect, but is it an educationally and economically significant effect is something we should all really care about. So let's unpackage the effect sizes here because I think the way people commonly think about does this effect really matter is a bit misguided, and I think this is kind of a case study of that. So we saw, for example, a 0.1274 increase in months enrolled per semester. Relative to the control group mean, that's nearly a 4% increase. And a common way in education policy to frame how big is that is to say, well, let's compare it to the standard deviation in that measure, right? And in this case, that's about 0.08. Now, a lot of people would say, well, that's pretty small. I think anything below 0.2 effect size isn't worth talking about. And I think that's misguided for a number of reasons. I mean, one of the key ones is you can't talk about whether an effect size matters without knowing, well, what's the cost of introducing that intervention? If I could give you 0.1 really cheaply, right, I think that's something we should pay attention to as policymakers. Moreover, my sense is that the effect size focus has come out of a psychological literature where people had instrumentation and were collecting data from self-reported questionnaires of things that didn't have a natural interpretation. And so the focus on effect size kind of grew out of a way of let's have a standard way of understanding what movement in this scale or that scale means. But we can think about attendance and enrollment and how big is big enough in different ways. So we don't have to just focus on that. So what else can we do? Well, basically two things I'm going to want to do. One is to think about how many more days are people actually in school and what's the potential monetary value of that based on other evidence. And also, how do the effect sizes compare to other achievement gaps we care about? So this increase in enrollment, given if you assume there are 20 school days per month, implies maybe nearly 3 additional days of seat time per semester. Doesn't necessarily seem that big, right? But one of the things you should note is how that gain, that treatment gain, compares to achievement gaps we care about. So this increase is about 13% of the gap between baseline dropouts and non-dropouts, and over 80% of the enrollment gap between males and females. So if we're talking about closing the achievement gaps, and I realize I'm sort of cherry picking what the benchmark is here, but it seems a little less trivial. Now we're seeing similar things for attendance. There's our point estimate, a 3.4 percentage point increase in the enrollment rate, which is around 4.5% relative to the mean, 10% relative to the standard deviation. And if you've got 90 days per school semester, which they did in Wisconsin, they have a 180-day school year, it implies 3 additional school days, roughly the same as the enrollment data. And that's pretty big relative to some of the statistically significant achievement gaps we see in school attendance. Okay, but this is something I've just added to this presentation. So if we think of these effects as being sustained for the full 6-semester study period, right? Which, again, we can't reject the null that there was that common treatment effect through the study period. The implied gain is 18 school days, right? So 3 times 6 semesters, 3 days times 6 semesters. So the treatment over the 6-semester window is creating 18 additional days of attendance. Now, given the 180-day school year, that's 10% of an additional school year. This is something I was literally doing these calculations I'm about to show you the other day, so I could rush the slide.
Is that actual attendance, or if they call it in and an excuse?
No, this is actual attendance, so it's they're in the seat. Okay, so that's something that I think labor economists feel pretty comfortable about monetizing, right? Because we've got really quite strong quasi-experimental evidence on what's the labor market benefit of an additional year of schooling from instrumental variable studies, and in particular these studies. I don't know how many people are familiar with the syntax. They have this so-called local average treatment effect interpretation. And what that means is these studies have leveraged natural experiments that influence school persistence at the secondary level for people who are at risk of dropping out. And so the interpretation of these wage estimates is that they're identifying the wage gain for that particular policy-relevant at-risk subpopulation of spending a little more time in school. So it's really well suited to the cost-benefit calculations I want to do here. And a conservative estimate, right, is that an additional year of school increases someone's wages by about 7%. Now, to underscore this, the way labor economists think of this is that this is an increase in your wages that is sustained throughout your working life, right? So it's pretty substantive. An additional year of school has really outsized economic impact. So
7 or 0.7?
So it's 7%. So let's think about what Learnfare did. It increased school year by 10%. So given this estimate of the effect to an additional year of school, Learnfare would increase your wages by nearly a percentage point throughout your life cycle. Okay, well, you still might be sitting there, that sounds really small. But the thing is, if you actually do the calculation to monetize that, it doesn't seem so trivial. So
it's bigger than the wage increases we're going to have at the university.
That's right. That's because it's positive, right? So what I did was I took data from the March CPS and I identified what do people earn over the life cycle from age 18 to 64, that stream of earnings, right? And I said, let's do the thought experiment where I increase that by 0.7% and then calculate the present discounted value of that increased income stream back to age 14. Begins at age 18, lasts till age 64, an additional 0.7% in wages. Discount that stream back to age 14. And what you get is a number that's nearly, using a 3% discount rate, nearly $6,000. So that's the present value of the additional schooling to someone who, his schooling was increased by this Learnfare treatment. So that's potentially non-trivial.
Did you use a median income for that?
So this is where doing it late Wednesday night, I'm not going to be as facile. So I used the March CPS data that I'd also used in a non-cognitive study of class size effects with Marty West. And so my recollection is we took the average, not the median.
Okay, because I'm just wondering if even the average is something we should be using, because
if it's positively skewed.
Exactly.
Right. Yeah, that's right. So that's a fair criticism. But you know what? I mean, even if you were to tell me it's 4,000 after I make that correction, I'm still surprised by how large that number is. Right? I mean, that's a pretty big present discounted value. And so if we could generate this kind of increase, for $1,000, the return on investment from this type of intervention, that might seem modest if you looked at effect size, right, is actually pretty considerable. So this is an example of what I don't like about effect size. Okay, but I want to talk a little bit more about what all this means. Again, the main conclusions, we saw these increases in the targeted outcomes outside of Milwaukee County. I don't want to forget Milwaukee County, though. In particular, you need high-quality implementation and data systems if you're going to do this well, because people need to know how their behavior is connected to the incentives, right? And it needs to be quick, transparent, and accurate. Everything it wasn't in Milwaukee County. But also, we don't really know what the impact of the policy was there because of this randomization failure. So one thing I want to put out there is that we think about Learnfare type of policies, we should also be thinking about how it compares to other effective dropout prevention programs, and there are some things out there. So for example, if you go to the What Works Clearinghouse, Check and Connect and ALAS have some pretty credible evidence that providing students with case management and support services can improve high school retention. So, and I'm not here to tell you one policy is better than another. I mean, this is more of an impact evaluation. But what I will note is that both cost effectiveness and scalability are also relevant considerations. And Learnfare type policies may be more cost effective. I haven't done that calculation. But they may be because they're not going to be as labor intensive as providing intensive case management and support. And I would also stress that some of these studies, in particular ALAS, I think was done at one high school serving a largely Hispanic population. Their external validity is going to be, whether they could scale up effectively is going to be relatively in doubt when compared to a policy like Learnfare, which was a mature policy that was implemented at scale throughout the state when these evaluation results were generated. I want to stress that, Learnfare suggests that incentive policies hold some promise. As I've been underscoring, the design, features, and implementation quality matter. Maybe there are some lessons in here for how we're thinking about principal and teacher incentives. But I also wanted to underscore the role of behavioral economics and using nudges in the design of policy too, because one of the things that was really unique about Learnfare was that it may have been leveraging the loss aversion phenomenon. And I also wanted to draw your attention again to this issue of targeting. The tasks that were targeted were attendance and not grades. So it's the fact that they were effort responsive might have also been key here. The incentives were to families rather than students. And I'm kind of agnostic on this question because some people who feel that incentives really need to be tightly linked to behavior, to work, feel it should really be linked to the student. Now the thing is, if students have self-control problems and don't care so much about the money, but whether their parents are going to ground them, you can tell stories about why it's better to incentivize families rather than students. I don't have a dog in that fight. I don't know which one is better, but this one was family-based and seemed to work in some sense. And again, I would also underscore, if you're going to do policies like this and replicate them, you might want to think about targeting populations with low levels of intrinsic motivation to lessen the probability that you have these unintended consequences. Now the final thought is, one of the things I think is sort of in the air with policies like this is we all feel a little bit queasy about these types of interventions, right? Because what are we doing? We're taking an economically and educationally vulnerable population. It's at high risk for all kinds of bad outcomes, and we're taking money away from them. I don't think any of us got into this business to do that kind of thing, right? Except maybe Pat. I'm kidding. But the thing is, the lessons from Learnfare suggest we could have policies that leverage these insights without necessarily harming people in that way. So, if I were Bill Gates or had access to the loose change in the couch at his foundation, one of the ways I might consider replicating this study, right, is not to take money away from people that they already have, but to go to a random set of chronically underperforming high schools with attendance problems and give everyone a scholarship, right? You're all opportunity scholars now, and you're going to get, $500, over the school year for each of your 4 years of high school. But then tell people, if you don't show up for school, we're aggressively sanctioning your scholarship. Right, so there you're in a situation where you're leveraging everything that may have been driving the approximate success of Learnfare, but not necessarily harming an at-risk population, because even people who end up collecting little of the money will still have more money than they would have had in the absence of that kind of policy intervention. So, I'll leave it at that and welcome questions. Yes.
Question not on the substance, but on replication. How did you get the data? Did you get it from the original authors? Was it in some depository someplace? This is a question because there's been an attempt to change the professional norms with regard to the availability of data
Yeah.
for replication. So I was wondering what kind of issues you ran into.
Yeah, and so this, part of what drove this project was that the data, for whatever reason, and I'd be interested to know how it came to be, are publicly available. So I was able to obtain them in that way. And I should stress that my initial interest...
From the authors or from...
From the authors. The authors were actually state officials in their sort of
okay.
Auditor General's office. And the data are publicly available on their website.
Well, that's an unusual circumstance.
And so it is. And I'd be curious to know how that came to be.
Yeah.
But also that was sort of how, sort of serendipitously, I came to be doing this project was, you know, I knew about the financial incentives literature, but to be honest, I wasn't that interested. I mean, when I first got wind of the renewed interest in incentivizing students, to be honest, I was a little bit embarrassed because it seemed as if people were taking the most sophomoric lesson in the discipline of economics and sort of going to scale with it and sort of playing to every stereotype about economists as having this sort of crude, brutally reductionist worldview. I'm sure you guys don't think that. And what drew me to this study was just as a methodologist, I was offended by the way they analyzed this random assignment study, because having really credibly exogenous variation like this is so rare and so valuable in policy settings. To not sort of drag the ball across the finish line is just really, it's like, to use a football metaphor, it's like having a poor red zone offense, right? It's like you got the opportunity to do something really great, but you couldn't get it in the end zone.
And did the authors respond to...
I haven't yet gotten a response from them, and I've had trouble tracking them down, so we'll see. When I'm in Madison, maybe I'll have better success. Yes?
Yes, you mentioned the importance of that graduation outcome, that it was treated poorly. That's what I heard.
Right.
So that was a goal, to see how many students persisted to the end of a year,
Right.
then to graduation, and whether treatment control made a difference in that important outcome?
That's a really good question. I mean, I would have strongly preferred this were a 10-semester study rather than a 6-semester study. Because remember, most of the participants entered Learnfare when they became subject to its restrictions at age 13. So we followed them as far as age 16. And there were some older people in the study, but most of them did not have completed spells of schooling. So when you run this regression, when you evaluate what was the treatment impact on the probability of graduating from high school or being a GED completer, we can't untangle those two in the data. There appears to be a positive Learnfare impact, but the p-value is 0.12. So it's falling a little bit shy of weak statistical significance. So and it's cooked into the way the study was designed. Because of the age cohorts they have, it's not well powered to detect high school completion impact, which would have been nice. But again, I would fall back on, because I've gotten criticism of this from people who've reviewed this study, that, oh, you're just finding attendance impacts, and what we really care about is degree completion. I would go back to those IV local average treatment effect estimates of the effect of what's the effect of getting an additional year of school on your wages, and the evidence is it's pretty substantive. That a little bit of secondary school persistence has real beneficial labor market consequences throughout the life. So I would prefer to have that outcome most definitely, but I don't think we need to deprecate these results because of it. Yeah.
Well, I don't want to deprecate the results, but I'm skeptical.
Go ahead, that's fine.
But since you mentioned the late IV thing at the end, I'm skeptical of it because I think that I don't know the CARD 2001 study, but
Right.
I think that those are sort of, I think that the effect there might be staying in school to a later age
Right.
versus more days of school. And you're not really measuring that.
So you think there's something about completing 11th grade that
Staying in
doesn't...
school until you're 17 versus dropping out when you're 16.
Yeah.
Or we
So
could use preschool and say, well, these people had an additional year of school. What is their lifetime
Right.
effects? We would find out.
Right. Well, I mean, this isn't bad. I mean, we're comparing, they're based on secondary school persistence, and that's what we have here as well. And so, yeah, I mean, maybe there's some sheepskin effects.
You're picking a bunch of days and adding them into
That's right.
something, an amount that is not necessarily added to the top.
Yeah. No, but remember, some of these studies return on changes in state compulsory schooling laws that really were moving the needle on school persistence at grades 9, 10, etc. Now, this was variation that was like, mid-20th century, so, the external validity for this is going to be suspect. But I don't think every one of those late estimates should be interpreted as moving school persistence in 11th and 12th grade rather than 9th and 10th. But to be hands above the board here, it's all a sort of back of the envelope cost-benefit calculation to just try to get at the question of, do these attendance gains, do they have the possibility of being economically significant? And I think that that's a qualified answer anytime you do that. If we were to do, I have to have my bona fides as a public finance economist, if we were to really do the cost-benefit calculation, there are lots of other things we'd want to bring into the picture too. Like, for example, if we were to fund this with new money, what was the deadweight loss that was created from distorting people's incentives and how you raise that money? But I think the notion that the economic value of those attendance gains is surprisingly large is interesting.
Tom, are you able to do any kind of a dose-response analysis in terms of, you mentioned that some of the students were more valuable to their families than others, and so there was more money at risk for them?
Yeah, that's a good question, and I hadn't talked about like what the sanction rates were either, and so you might imagine, I did that crudely by looking at subgroup results, right? Because I broke out the results by teen parents in particular, because that's where you really see a sharp dosage distinction. And the effects look larger for the teen parents are largely teen moms, 98% of them were females. And you see a substantially larger effect there, but there's not a lot of precision. There might be other ways to do that by sort of identifying the amount at risk and potentially using kind of an IV strategy on that, kind of generate a treatment untreated estimate. And I haven't looked into that. I'm not encouraged it's going to have much power just because of the subgroup results. Yes?
You had some, you talked about effect size, and a couple of your tables, you reported R-square values, and there's a couple of things that just kind of struck me funny. One was when you talked about the effect over the 6 years. And it had a fairly large R-squared. What was that R-squared reflecting there?
So if you saw an R-squared, it would have been for the whole regression. So so this is the whole regression, and that's pretty high for a cross-sectional panel data set. And I think part of what's going on here is these are the fully saturated specifications, where I took each of the 9 counties, each of the 6 semesters, each of the 14 months. And so you've got 9 times 6 times 14 fixed effects in that specification to control for all the possible interactions. Oh, it's in this semester, but I entered at this time, so I've been in the study for so long. Or I'm in this county, but in this semester when there are these local labor market conditions. And so I think soaking up all the unobservables that might be correlated with those fixed effects is what's driving the R-squared up.
Okay, the other was I think it was table 3, where you were comparing Milwaukee to the others. And it looked, and I just noticed that the R-square for the other counties that was not significant was actually larger than the... Yeah,
so that's really, and that's what we'd expect, right? Because remember, the dependent variable in this is randomly assigned, right? So you wouldn't expect a lot of the variation of it to be explained.
Well, but I'm comparing the 2.
Oh, you're comparing the 2.
Yeah, see, the one's got a P of 95 and the other has a P of 0.000.
Yeah, they also... That's right. They also have different sample sizes too. So I'm not
that different.
Well, it's just Milwaukee is about twice the sample size as the other 9. So I'm not sure if there's anything meaningful you should attach to that. The key thing is none of these observables predicted either individually or collectively what your treatment status was.
Okay, but you still got a greater R-squared on the right side than you did on the left.
That's right. Yeah. Okay. Yes.
I'm attracted by your suggestion that we ought to do something to replace effect sizes, because I can tell you that if you describe effect size to a state legislator, that person has no idea what you're talking about, and it's this particularly useless sort of thing for policy consumption. And translating things into dollars makes a lot of sense. Everyone
Right.
understands what a dollar is.
That's right.
So what if we were to try to develop a convention where we translate everything into dollars? Now,
Right.
the downside of that, though, is we'd have to agree and have confidence in the relationship between all these different educational outcomes that we're measuring and
Right.
dollars. And Brian has already gotten at a concern. There's a difference between attainment, attendance, and achievement. And so
Yeah.
what's our relative accuracy in predicting lifetime earnings from each of these three different measures?
Yeah.
And how fluidly can we move between them? And if we actually can do this all with confidence, can we make a push for getting rid of effect size and just make everything into dollars?
Yeah, well, I mean, I don't think I necessarily would want to go that far. I mean, Brian's criticism, I think, was a really sophisticated one. I guess my feeling is, let's do it all these different ways, right? At least within our research discourse. So we have multiple angles for thinking about how big is that effect. As an aside, on the sort of policy and legislative side, I was reading on the plane here, it might have been the Gadfly Digest or something like that, that there's some senators have authored some NCLB reauthorization language that want to codify 0.2 effect size in a new definition of what constitutes scientifically based research. Now, I guess part of the reason I felt emboldened to do this simple back-of-the-envelope calculation and wasn't worrying about some of the issues Brian raised, related to sheepskin effects and things of that sort, is the standard for monetizing these is so low. So, for example, if you look at the Project STAR evaluations, where we move the needle on test scores for elementary, for kids in grades kindergarten through 3. So what people have done in discussions of that is to say, well, what do we know about the labor market effects of having slightly higher test scores? And they would just take the evidence from simple multiple regressions, right? Where what's the regressing wage on baseline, say your test scores in high school, and there appears to be such and such an impact, when of course it's just a partial correlation, right? It could be picking up lots of other things, but by God, it's monetizing those test score gains. And then, so what if it was, based on 8th grade or high school test scores? Let's apply it to these kindergarten test scores to monetize the gains of the class size reduction. So I felt much more confident doing it in this context because at least we've got, reasonably credible quasi-experimental evidence, right, that moving the needle in secondary school persistence has such and such wage impacts. And I'm not saying we shouldn't do the latter, even though it's potentially subject to much more criticisms than the back-of-the-envelope calculations I did here. I think we should still do it, but I don't think it should usurp other ways of thinking about effect size. Right? I'm okay with doing effect size, but let's also frame it with regard to achievement gaps. Let's frame it with an eye towards what's the cost of the intervention that's moving the needle by a given amount. All of those things should be in the mix.
Although I suppose the danger is that when we monetize everything, that everything looks there's such a fantastic return,
right,
that we could actually infinitely increase wealth. If only we would try every scheme that based on Perry Preschool with 100 kids, we're going to get a 1,000,000% return. And
right.
It's going to
right.
just give all wealth to the government and have various interventions.
Right.
Little interventions to get
yeah.
the economy
There's
going.
definitely a reductio ad absurdum here in that.
Well, but it makes me worried that in your effort to make this effect, to convince us that the effect is big,
right,
that maybe you're overreaching, and that
right,
maybe the effect is kind of small.
Right. Well, so that's right. It's a back-of-the-envelope calculation. If we were to say, well, where should we move from here? I'd want to talk about what goes into structuring the policy. And now, given the way they've structured it now, you're generating this benefit, and at least with regard to the state, it's very little cost, right? Because all they had to do was set up the data systems and run the program, and they're actually clawing back money, right? By taking back money they would have given these people and re-entering it in the state coffers.
That's an infinite percent return.
Right, that's right. Well, the thing is, you do have to take into account those people are losing. Another way to frame it would be to take how much money they're losing as a result of the treatment and compare it to the present discounted value of the gains they're realizing because of their increases in human capital investment. And, you know, I had to go to bed Wednesday night, so I haven't done that calculation.
Any final question for Tom? Okay, well, thank you.
Thank you. I really